All right, let's look at one more example of a chi-squared test for independence. So this one is about diabetes in the Native American population. So preventable chronic diseases are increasing rapidly in Native American populations, particularly diabetes. We have a contingency table showing the cross classifications of educational level and diabetic state for a sample of 1,273 Native Americans. At the 1% significance level, does the data provide sufficient evidence to conclude that an association exists between the variable educational level and the variable diabetic state and that's for Native Americans? So what I'd like you to do is actually pause the video and give this a try. The data set is all ready for you in Excel, so you don't need to fill this table in unless you're wanting to do it by hand, but you certainly can, or you can just do it in Excel. In terms of doing the homework, I would just copy and paste that table right out of Excel into your Word document or print it. But go ahead and pause the video, give that a whirl, and then we'll come back and fly through it and see if we got to the same place. Okay, so hopefully you gave that a try, and I'm hoping you gave that a try in Excel. So we are being asked to look at, is there an association between the education level and diabetic state for Native Americans? So our null hypothesis here is going to be that ed level is independent of diabetic state. And my alternative hypothesis is going to be that ed level is not independent. In other words, it's dependent with diabetic state. Okay. We have 3 assumptions and conditions to check, and this is where we work on getting those expected values. So I need some sort of random sample. And I don't believe that's actually stated in the problem that we have a random sample, so I'll mark that not stated. Unless I missed reading something, I'm sure one of you will let me know if I did. The expected counts all need to be greater than 1, and at least 80% are 5 plus. All right, so let's switch over to Excel and see how we do with this. Okay, so here we are in Excel, and here's our observed data, and I'm on this diabetes tab. To get my expected data, I'll do equals, I'll put my row total times the 95 divided by 1273. I'll do the same thing for the no diabetes, so equals my row total times 1178 divided by 1273. And then I can copy and paste those all the way down the table. And so now I have all of my expected values. So I can pull a p-value here by using that chi-squared.test command. I'll highlight my actual or observed values, put a comma, and then highlight my expected. Okay, so there's my p-value. And if I'm looking for my test statistic, that formula is equals, and I'll do a parentheses, observed minus expected. And we'll square that and then divide it by the expected. And I'm going to copy that going across, and I'll copy this going down. So I have all the parts and pieces for my test statistic, and then to get that, I just need to add all 8 of those boxes up. So that's equals the sum. Oops. There we go. And I'll just highlight all 8 of those. So I get 17.5 for my test statistic. Okay, and then let's see what we get for our p-value. So equals, we'll do the chi-squared.dist.rt. So I'll click on my test statistic here, and then I'll put a comma, and then I need my degrees of freedom. So I have 4 rows. So if I subtract 1, that gives me a 3. Then I have 2 columns, and if I subtract 1, that gives me a 1. So 3 times 1 is 3. So that's my degrees of freedom. Okay, there we go. Exact same p-value as we're expecting. So I'm going to go ahead and write that down, 0.0005. And then we'll switch back over to the paper and finish the problem up. All right, so when we looked at the values in Excel, none of them were less than 5, so we can mark off all of these. In fact, I wrote them down so we can just double check here quick. None of those are less than 5, so we can check off our assumptions and conditions. We're doing that chi-square test for independence. I got 17.5 for my test statistic and 0.0005. My alpha was 1%. So it's 0.01. My p is smaller than my alpha. So I do reject my null hypothesis and my conclusion statement. So with p equal to 0.0005 at the 1% significance level, we do have sufficient evidence that there is an association between education level and diabetic state for Native Americans. All right, so there is our second attempt at doing a chi-square test for independence, and hopefully that didn't go too fast. I'm hoping you all tried that out beforehand so you could just fly through with me and make sure you got to the right place. As always, if you have questions, feel free to send me an email or catch me on Zoom.